In this module, you will learn about securing the Jenkins instance and also scaling the Jenkins infrastructure by installing multiple nodes. So let's get started. We will begin the discussion with configuration of security for our Jenkins server. Why should we start with a discussion on security? Because security has implications on the subsequent discussions about scaling the Jenkins infrastructure to multi-node clusters. So understanding the security configuration will help us later when we install Jenkins slaves and connect them to our Jenkins master server. Let's get started with securing our Jenkins server. Click on the Manage Jenkins menu on the left-hand side, and on this Manage Jenkins page, click on Configure Global Security. One of the first options we see is to be able to configure our TCP port for Jnlp agents. This is the TCP port on which our master Jenkins server will allow the slaves to connect via Java-based technology called Jnlp. Jnlp stands for Java Network Launch Protocol, and it enables an application to be launched on a client by using resources that are hosted on a remote web server. These Jnlp port settings play a critical role when connecting slaves to the master Jenkins server. So let's configure this first. By default, this port is disabled, but to enable it, we have two options. We can either set it to a fixed port or a random port. Under fixed option, we will need to provide a specific port for these connections. This option may be better if you are behind a complex corporate network and you have to configure firewalls between master and slave nodes. But for usual setups where all master and slave nodes are in the same network, random port is recommended. Here, Jenkins will pick an available port automatically. So we will pick the random option here and move ahead. Next, we come to the access control section. This section controls the core of the security and permission settings. When users log on to Jenkins UI, they are authenticated and an appropriate set of permissions are assigned to them based on these settings. The security setting within Jenkins is controlled mainly by two axes. Security realm, which determines users and their passwords, as well as what groups the users belong to. Authorization strategy, which determines who has access to what. These two axes are orthogonal and need to be individually configured. For example, you might choose to use an external Ldap server like Active Directory as the security realm, and you might choose everyone full access once logged on mode for authorization strategy. Or you might choose to let Jenkins run its own user database and perform access control based on the permission user matrix. Here are the configuration sections where you can configure both these security axes. By the way, please do remember that for each of these options, there is a handy tooltip available with detailed documentation. All you have to do is click on this question mark icon and the helpful tip will pop up. Delegate to server container. This option is only applicable to older versions of Jenkins. For Jenkins version 2.0 and above, this option is not applicable. This next option is to use Jenkins' internal database to store the user information. Using this option, we can also select this option to allow users to sign up for a Jenkins account. Although, this option should only be turned on with extreme caution. Next is Ldap. Ldap stands for Lightweight Directory Access Protocol. It is an application protocol that is used over an IP network to manage and access a distributed directory information service. The primary purpose of a directory service is to provide a systematic set of records, usually organized in a hierarchical structure. Windows Active Directory is one example of an Ldap directory. So basically, this option allows us to secure Jenkins based on corporate network credentials. Unix User Group Database. This is similar to Jenkins User Database, but instead of using the internal database, this option will use Linux or Unix users and groups for authentication of the users. Unless you have any specific requirements, in most cases using the option of Jenkins' own user database will be sufficient. Moving on to authorization. The first option of anyone can do anything is the most liberal option, but it is the most insecure. This allows for anonymous users to pretty much take control of the Jenkins server and make any kind of changes. So it is not recommended that we select this option, especially in production environments. Moreover, since Jenkins server is secure by default, if we select this option, Jenkins will lock down some necessary functions. For instance, it will not allow us to manage user credentials or allow new users to sign up. The next mode is the legacy mode, which means that only administration users can manage and make configuration changes with Jenkins. Basically, under this mode, all non-admin users can read Jenkins configuration, but not change it in any way. In some situations, this option can be very useful. What is logged in users can do anything? This is similar to the first option, anyone can do anything, but the difference here is that Jenkins forces the users to log in. Once they are logged in, they basically have administrator privileges. Just like anyone can do anything option, this option is not recommended either. This is because giving too many privileges to users may potentially break the CICD process because these users may make mistakes or break the process maliciously. Furthermore, this option can also allow anonymous users to view Jenkins in a read-only mode. The most useful and frequently used options are matrix-based security and project-based matrix authorization strategy. They are very similar in the functionality they provide. The most significant difference between them is that matrix-based security is for entire Jenkins infrastructure, while project-based matrix authorization strategy can allow you to manage security access for specific projects. The latter could be quite useful if you have numerous subteams who are sharing a common Jenkins infrastructure. In that situation, specific projects can be assigned to specific subteams, and they can all share the Jenkins instance without stepping on each other's toes. For a small-scale cluster, matrix-based security is a good option. Let's see how we can configure it. Let us start with some users here. If you don't have any users within your Jenkins instance, you can configure them under the Global Security Management section. Anyway, let's add the required users here and configure their permissions. Say we add the root user. If this is a known user to Jenkins, then this root will be represented by this little blue icon. This means root user already exists in our Jenkins user database. Let's try to add a new user to Jenkins. Name this user Deploy. And now you will notice that the user icon has a little red X on it, which signifies that there is no such user in our database and Jenkins does not recognize it. Before we can log in as this user, we will need to create it. Let's delete this Deploy user for now, and let's give our root user all the necessary privileges. One important thing to keep in mind while using this matrix-based security settings is that you must assign this overall read permission to every new user that we want to be able to use Jenkins. Without assigning this permission, our users wouldn't be able to access the system at all, and they will be locked out. So this option is essential. As you can see, this matrix-based security settings allow us to assign fine-grained permission control to our users and user groups, like permissions to manage credentials, permissions to manage agents, manage jobs, etc. Not only that, even the plugins we install could have specific permissions controlled within Jenkins. For instance, we can assign permissions for specific users to manage Artifactory. Alright. Now our root user has all the permissions to do pretty much anything with Jenkins. Let's click Apply and save our configuration. Now let's go ahead and create some new users. We will click on Manage Jenkins and then click on Manage Users. Here we can click on user menu on the left-hand side and create a new user. For example, let's create a user called test1 with password test. Full name of test and email address of test@tetranoodle. This new test1 user has no privileges within Jenkins. This means this test1 user will not be able to access Jenkins or make any modifications to it. To configure security for this particular user, we can click on Manage Jenkins again, and then Configure Global Security. Here under the matrix-based security option, we can add our new user and configure necessary permissions as needed. For now, let's just give an overall read-only permission to this new user and click Apply and Save. In the previous lecture, we configured Jenkins security. In the process, we created a new user and configured fine-grained permission for our users. After configuring the security of our Jenkins instance, we are now ready to scale our system by adding slave nodes to our infrastructure. Now let's go through the process of adding Jenkins nodes to our Jenkins cluster and scaling our Jenkins infrastructure. Jenkins supports a scalable master-slave architecture, where the workload of building projects can be delegated to multiple slave nodes. This scalable master-slave architecture allows a single Jenkins installation to host a large number of projects, or to provide different environments needed for builds and tests. A master, operating by itself, is the most basic installation of Jenkins, and in this configuration, the master handles all tasks for your build system. If you start to use Jenkins for increased load for multiple projects, with just a single master server, you will most likely find that you will run out of resources, memory, CPU, etc. At this point, you can either upgrade your master server or move it to a more powerful machine. Or you can set up slaves and scale horizontally. In this mode, the additional slave nodes will pick up the load. As mentioned earlier, you might also need several different environments to test your builds. In this case, using a slave to represent each of your required environments is almost a must. For instance, you may have several projects, some of which need Linux operating system for testing, and others may need Windows operating system. For this setup, it will be essential to install Linux and Windows slave nodes. Of course, one of these required hosts could be a master. A slave is a computer that is set up to offload build projects from the master, and once set up, this distribution of tasks is fairly automatic. The exact delegation behavior depends on the configuration of each project. Some projects may choose to stick to a particular machine for a build, while others may choose to roam freely between slaves. There are various ways to start slave agents, but in the end, the slave agent and Jenkins master need to establish a bidirectional communication link, for example, a TCP IP socket, in order to operate. Alright, after that brief overview, let's go through the process of creating our Jenkins slave and connecting them to our master. Let's refresh our memory about our environment here. Our host operating system is a Windows machine, and our Jenkins server is running within a CentOS virtual machine hosted within a virtual box on our Windows host. For our cluster setup, we will install a Jenkins slave agent on our Windows host machine and connect it to the master server running within our CentOS virtual machine. So basically, we will install the Jenkins server on the host machine and configure it as an agent. To get started with the installation, we will go to the official Jenkins website and go to the Download Jenkins page. We will download the Windows installation package for Jenkins from here. Let's wait for the download to finish. Alright, now that we have the installation package downloaded, all we need to do is run it. We will go through the installation wizard and accept all the default values to install Jenkins on our Windows host machine. Let's wait for the install to finish. Okay, click Finish to complete our installation. Now we have a full-fledged instance of Jenkins running on our Windows host. We can access our Jenkins instance by navigating to localhost, port 8080 in our browser. The actual process of initial configuration for Jenkins is almost the same as in Linux. The only difference is where to get the initial administrator password from. On Windows-based systems, the password can be found under Program Files /Jenkins/secrets/initial admin password. Let's go find this file and get our initial password. We will navigate into the secrets directory and open the initial admin password file with Notepad. Here is the password. Let's copy it and paste it into our configuration window right here. So as we said, the rest of the process is pretty similar to the one we walked through earlier. We will install the suggested plugins and accept defaults. If we need some additional plugins in the future, we will search and install them later as needed. Installing too many plugins ahead of time may also cause various issues like performance issues, misconfiguration, and security-related issues. We've encountered in some situations where in big projects, Jenkins had too many plugins, and after running the system for a period, things got so convoluted and unwieldy that it becomes hard to trace which plugin is doing the necessary steps. Anyway, after our configuration has completed, let's create our first admin user. We will keep things consistent and use the same root user here as on our Windows instance. Username is root with a password. The full name will be Tetra Noodle with an email address of tetranoodle@root. Now let's click Save and Finish. Great! Our initial configuration is all done. Now let's start using Jenkins. Okay, here we are on our Jenkins homepage. You can see the interface is identical to our Linux instance. So just to recap here, we are working with two Jenkins instances now. We have opened the home page for our two separate Jenkins instances in two separate tabs of the browser. One is the local host instance, and the second one is our CentOS virtual machine instance. Here is the localhost instance, and here is the jenkins.noodle.tetra instance, which is our CentOS instance. Now let's go ahead and connect our slave with our server. On our CentOS server, we will click Manage Jenkins and then click on Manage Nodes. This page lists all the nodes which are connected to this master. As we can see right now, we only have a standalone server, so we only have one master server listed here. To add a new slave node, let's click on the New Node menu. Let's name our node Windows OS and select this permanent agent option. This is permanent because Jenkins does not provide any dynamic provisioning. Basically, once the Jenkins instance assumes the slave role, then it will be permanently connected to the master as a slave. We will click OK to proceed with the configuration of our new node. Here, description for this node is optional. The maximum number of Jenkins jobs is dependent upon what you set as the limits in the master and slaves. Usually, we specify this limit based on the number of CPU cores in your slave machine. But your mileage may vary depending upon available memory, disk space, availability of SSD, and overlap of source code. The limit is controlled by this setting, number of executors. For our new slave, we will set it to 2. The remote root directory is mandatory, and we need to specify the path to our Java home directory here. Please note the path is the actual path on the slave machine. Next is our usage setting. We can set our slave to be used to its maximum capacity and at the discretion of the master. Alternatively, we can be more selective and assign it only particular builds. For instance, say some components may need a test framework to run test builds. so we can assign it dedicated servers where this testing framework is installed. Here we select Use this node as much as possible and launch agent via Java Web Start. Let's check Advanced button, which will enable us to specify some additional options like JVM custom options. But for now, we will accept the default values for the rest of the settings and click Save to save our node configuration. Okay, great. Now we see a new node defined in our list of nodes. Now, since we have configured our network such that both our host and the virtual machine can connect to each other, it is rather straightforward to connect these two Jenkins instances together. In your own environment, please make sure you are on the slave node with a browser instance launched on the local slave node. And from there, you navigate to the Jenkins master server homepage for this connection to go through as smoothly as possible. We will click on our Windows OS instance to get the details page for our new node, and click on Launch button to launch the agent from our browser window. One word of caution here. Sometimes the Jnlp launch may not work due to some misconfiguration. In that case, it is helpful to run this batch command to troubleshoot that problem. Anyway, let's click on the Launch button and wait for the agent to launch. Upon clicking this button, it has downloaded an installation file with the extension of Jnlp. Let's run this file to launch the agent. This Jnlp file is called a Java Web Start file, which allows you to download and run Java applications from the web. If you see any warnings or prompts to proceed with running this application, please agree to those and click on Run to launch our agent. Looks like our agent has started and connected successfully to our master. Once it is connected, we can go to the Jenkins homepage for our master Jenkins server, and we will see 2 new executors have been added to our cluster on the Windows OS node. Our main CentOS instance is master, and our Windows node is connected as slave. We have a total of 4 executors, and all of them are idle right now. Okay, now let's change the configuration of our cluster such that all new jobs are assigned to our slave node on a preferential basis. We will click on Manage Jenkins on our master server. Click on Manage Nodes, and we will click on Master Node to make the necessary configuration changes. Here we will click on the Configure menu on the left-hand side. Under the usage setting, we will change it from the default value of use as much as possible to only build jobs with label expressions matching this node, and click Save. With this change, any new job which is queued will only run on the master node if it matches certain conditions. Since we specified usage of use as much as possible on our slave node, most, if not all, of the build jobs will be assigned to our slave node. Now let's go to our Jenkins homepage. Let's create a simple job to verify our slave and master connectivity. All this job will do is execute a Windows batch command. We are going to use Windows batch command instead of shell command because this job will execute on our Windows node. For the actual command, all it will do is print a phrase on the command line, Tetranoodle tutorials. We will specify this by using the echo command. Okay, there we go. Let's click on Apply and Save. Let's run this job and observe how this job gets executed. As we can see, our job built successfully, and it was executed on Windows. Jenkins is a highly scalable framework and is perfectly suitable and capable of handling tens of hundreds or even thousands of builds simultaneously. It is suitable for distributed and large teams and subteams. It has all the features to securely run the complex build systems in a highly dynamic environment. Not only that, Jenkins supports a plethora of technologies, languages frameworks like Java, JavaScript, Ruby, C#, Golang, etc. To scale to these highly concurrent and demanding levels of efficiency, we need to build scalable and distributed clusters of Jenkins nodes. Even with memory getting relatively cheap and multiple core CPUs becoming commonplace, running such a large system on a single Jenkins machine will be almost impossible or prohibitively expensive. So we must think about scaling out with the user of master-slave architecture, which is supported by Jenkins out of the box. Now in this session, we will discuss some tips and tricks that you should keep in mind about setting up these highly scalable clusters of Jenkins infrastructure. First, let's discuss the master node. As mentioned earlier, the master Jenkins server is the central controller node which coordinates and assigns build jobs across the cluster of nodes. So it is very important that we keep the master Jenkins node very responsive, especially since most people accessing Jenkins will do so via the web interface, which is running on the master node. Try to remember that running and managing build jobs is a demanding task and requires a lot of memory and CPU resources, so it is advisable not to run any jobs on the master node. If you are involved in large projects, and if you choose to run your jobs on the master node, you may run into situations where the master node is overwhelmed while running the build jobs and has no resources left for running the web interface or managing other aspects of the Jenkins cluster. As such, the master node may become unresponsive, or worse, the cluster may suffer an outage. Furthermore, to protect against these disastrous scenarios, don't forget to make regular backup configurations for your Jenkins master node's configuration. Now moving on to the slave nodes. First of all, the slave node should be quick to set up and throw away if they suffer any type of software or hardware issues. Plan your slave server for high usage and optimal efficiency. It should be utilized to the maximum capacity, and you should run multiple jobs on it, not just a single job. Always plan the slave node's hardware for really high usage. Regularly and diligently monitor your CPU and disk usage over the slave nodes. It is also a good idea to segregate heavy and more complex jobs to a separate set of beefy servers, so they do not end up blocking the smaller and quicker jobs in the queue. In case any of these jobs are too demanding, it is even advisable to isolate them and assign them to dedicated slave nodes, so that they do not end up affecting the efficiency of the entire build queue. That is how you will avoid all problems with accidentally failed jobs. Another good practice is to pick your plugins for Jenkins responsibly. Once installed, please ensure they are configured properly, and you regularly update their versions. Moreover, please also take care to clean up unnecessary plugins. These unnecessary plugins may end up cluttering the whole system and may cause unforeseen issues. Another good practice is to install and configure logging and monitoring for your Jenkins nodes themselves, so that you can easily and quickly troubleshoot the problems when they arise. Another good practice about build jobs configuration is to keep the logic for the build job simple and straightforward. Try to avoid too many steps in a single job. If you do need multiple steps, it may sometimes be easier to break them into logical groups and configure them as separate jobs which are chained together. This achieves the same purpose, but the build configuration is much easier to maintain when they are of manageable size. Avoid using any complex logic in your shell command steps. We use shell commands in our course because most of the jobs needed very straightforward shell commands without any direct rules embedded in them. As the complexity of the jobs grow, using too many shell steps just multiplies that complexity exponentially. Another usual problem you may run into is source code management and its integration with Jenkins. It is always a good practice to manually pull the source code on the Jenkins node and verify whether Jenkins can access the source code directly or not. You can even take it one step further and run the entire build manually on the node before automating it with Jenkins. What are some concerns about archiving your artifacts in Jenkins? Jenkins is not optimal at this at all. This is why we suggest you use a repository manager like Artifactory for storage and management of your build artifacts. These solutions are much more robust and easier to manage than vanilla Jenkins. Moreover, most of these repository manager solutions work really well with Jenkins in most cases with the help of plugins.